The first time I saw this thing printing upside down, I had questions. Like, that's a clear piece of glass. How are they heating it up? Can I bring it to a park and print off-grid? And how the heck does a 3D printer that's better than my Ender fold up and fit inside a filament box? This is the Positron V3.2, and the story of how it was built and how it works is incredible. It comes as a $700 kit you have to put together yourself. And if you don't already have a 3D printer, it's another $99 for the 3D printed parts. So no, it's not for everyone. But after you see it print, you just can't look away. The little system of pulleys that makes the print head move around is mesmerizing. Seeing the first layer print through the glass is mesmerizing. In this video, I'll talk about how I built it and whether there are any advantages to upside down printing. But one thing I can't test, at least not today, is what happens when you bring it to Australia. First of all, why upside down? That's the #1 question people ask when they see this thing. The main reason for that is to keep the tool head and motors all in the base. Keeping the center of gravity low and putting all the heavy parts on the bottom means you don't need a strong frame to hold it all up above. And if you don't need a strong frame, just a stable Z-axis, you can more easily break it down so it fits into a smaller case. And the filament box thing is kind of a party trick. I tested it once and it works, but for real portability, Positron includes a more protective Pelican-style case with custom foam inserts. And people have already taken it through airports to events, and even in one case on a family vacation. I'll test out portability later, but before that, since this was my first time ever building a 3D printer from the motors up, let me walk you through that process. I learned a lot. Like, did you know this thing has not 1 but 3 Raspberry Pis built in? There are 2 RP2040 microcontrollers, and then a whole Compute Module 4 running Clipper that controls the whole printer. Everything's open source, which I love. And before I get into the build, I should mention that Positron and LDO Motors sent me this kit. I talked to them at OpenSauce, and I couldn't refuse their offer. So no, I didn't pay for this printer. But they also didn't ask me to make a video, and they had no input into this video, so let's get started. First off, the thing came in 2 boxes. One box had all the 3D printed parts. The other one had the travel case, CNC parts, the glass bed, the power supply, and all the little screws, springs, motors, and everything that makes up a 3D printer. The kit comes with a checklist, and LDO really wants you to triple check everything is accounted for. I spent 30 minutes or so checking off every item, but couldn't find this little hex female standoff. Luckily, after rechecking a few of the baggies with multiple items, I finally found it. With everything accounted for, the first step was putting together the extruder. At least part of it. The way the build goes, you first put together a bunch of the smaller assemblies, then at the end you install all of them into the main body. And since my son had a little time this summer, I also had him come and help with the Z-axis, which was the next step. He was happy to see the thing come together, and at the end, it glides smoothly on the rail and the extruder spun freely, so it was on to step 2. And for almost every step, there were heat sets. A lot of the printer is rep-rap style. That basically means when you build a 3D printer out of 3D printed parts. There's actually another Positron version out in the wild with a frame that's almost entirely rep-rap, but this one has mostly 3D printed parts with some solid metal frame pieces to keep it more compact. The heat sets are easy to install with the right tip, but you could use a regular soldering iron tip too. The key is to align it as perfectly flat as you can and recess it just a hair under the surface. Now, the whole process is documented with excruciating detail. Being one of the first batch of builders, there were 1 or 2 little rough edges in the documentation, but on the whole, for someone who had never built his own 3D printer before, I can say it was pretty straightforward, even fun at times. That didn't mean it was perfect though. One little standoff snapped off when I tightened it. Luckily, since I have like a zillion extras from my Raspberry Pi work, that wasn't a problem. I just drilled out the screw that was stuck and went along with the rest of the build. And I'm glad I have a big open desk to work on. This build really takes up the whole space. I tried to keep my screws organized at least by type and kept the electronics in one area, motors and rails in another, tools and 3D printed parts over on the right. It wasn't the cleanest setup, but it was organized enough that I got a feel for where things were after a few hours. Now, I mentioned there were some Raspberry Pis in this build. When I installed the main board that controls the fans, motors, and end stops, I spotted my first RP2040 chip. Then when I was putting together the tool head, I found another one. I guess that one controls extrusion and bed leveling and heating. Then of course there's the Compute Module 4 on a custom touchscreen board, which winds up being a very compact and functional Clipper controller. When I got to the frame assembly, there were another 20 heat sets, and once those were in, I started putting the main body together. And that's when I realized a few of the 3D printed parts had supports on them that looked like they were part of the frame, but they actually weren't. These are supports, these little things here. And they got in the way of things. And I put heat sets right through them, so I'm going to need to remove those heat sets and try this over again. I got them off of this one, so I think I can get them off of here, and those heat sets will just be trash. I might be able to clean them up, but anyway, double check that you remove all supports before you start putting parts together. And even with really good instructions, a few steps are just a bit tricky, like trying to get these idler pulleys installed with some tiny spacers you have to install blindly. It's probably the most annoying part of this whole build. Luckily, you can just tip over the whole thing and the washer will fall out if it falls down in there, but you can see it can fall in there, and then these aren't magnetic, so getting them out requires a little tweezers. But wow, once the frame started to come together, it was looking really nice. Like, I'm sorry Prusa and Bambu, this thing actually looks cool. They even have this fun little brace across the front edge with the Positron logo. Kudos to Kraylin and the Positron team for all these little design details. More heat sets and more wiring, and eventually I got the tool head working. The wiring for the tool head was a bit picky. I think through the entire build, getting all these wires to go in the right place on the tool head was probably the hardest part of the whole thing. I mean, I know I'm terrible at cable management, but this was tricky, and I didn't want to mash any cables because some of these things are carrying a lot of current for the hot end that heats up the filament. And on the theme of cable management, these two belts you install are actually pretty straightforward in how you route them around. There's a nice illustration in the guide for it, but the hardest part was getting the slack into the little retainers. It was just a matter of mashing them in, but a better retention system would be nice. Finally though, it was time for the first power on tests, which went horribly. Well, I guess it could be worse. I have everything plugged in, and it could go up in smoke, or not. Well, that was disappointing. Luckily, after tracing the power back to the power supply, I figured out the power cable I was using didn't work with the power adapter Positron sent. Not sure why, but I was only getting like 0.3 volts on the barrel jack. That's definitely not enough for a 3D printer. But I came back the next day and used the power cable Positron shipped. Okay, it's finally time for the first power on. The first time I tried this, I actually had a power cord that somehow wasn't supplying power. But now this one is. I can confirm I'm getting 24 volts here. I'm gonna plug it in and hopefully there's no magic smoke. We'll see if that's the case. Plugged in. There's a light. That hopefully is a good sign. I just saw a light blink on here. And I hope this is booting up. And it says in the instructions to run the nozzle dock macro. So far so good. There's a sharp corner there that I'm only slightly worried about with this cable. You can tie the Teflon tube to the tool head cable. The Teflon tube is not installed. That was not part of this. I got familiar with Clipper since this was my first time using it. It's basically an advanced OS for 3D printers with a ton of community support. It runs great on a Raspberry Pi, and LDO shipped a tweaked version that has Wi-Fi support and a web UI built in. I ran some updates, marveled at the RGB LEDs for a few seconds, then started bumping into some issues. First, I noticed if I loaded up the filament, gravity kinda makes things messy. This is a running theme, and I'm still trying to figure out the best way to deal with it, but anytime I start a new print or load in new filament, I have to use some pliers to pull off some of the ooze. Otherwise, when the print starts, the print head can make the first layer a little messy with the goo stuck on the nozzle. Then I also noticed the Bowden tube, this tube that helps route the filament inside the tool head, was catching on the x-axis a lot. That's actually a known issue with batch 1, so hopefully they have a permanent fix. I'll tell you how I fixed it later. I was finally ready for a print, but I'm used to using Prusa Slicer for my Prusa, Bambu Studio for my Bambu, and Cura for my Enders. None of those apps had any Positron profiles, so when I asked about it, they recommended Orca Slicer, and they added a nice little note on the end of that line in the wiki. I sliced up a calibration cube and fired off the first print, but had to stop it. The Bowden tube was catching and the first layer wasn't printing cleanly. The build plate was too close to the nozzle, and apparently that was another issue with batch 1. Status update. First print was a fail, but I think that it's because they were saying the Z-axis height based on this little IR sensor is off sometimes. And then also 2 times now it started printing, and then it got caught on this, and this was pulling really hard, and it was jumping, so I don't know how to fix that. When it comes back here, this kind of sags down. But the community has been hard at work with mods and fixes. First, I soldered up the Z end stop mod. Basically, you replace part of the extruder, screw in a little end switch, and plug it into the main control board. Move a jumper, update the config, and it'll home the Z-axis a little better. Working on your own printer build really helps you understand some of the little details, like how the print bed works or how the motion system works. It's actually made me appreciate just how well Prusa, Bambu, and even Creality tune their printers to work well out of the box. But after tweaking the Z height and leveling the bed, and after 2 more failures, I finally had success. All the parts of this printer I had spent about 12 hours assembling by hand were working together to move the bed, move the nozzle, extrude filament, and ultimately make this little calibration cube. If you wait a minute for the bed to cool down, it just pops off. And looking closely, is it perfect? No. But is it my favorite experience with a 3D printer so far in my life? Yes. But there were issues. I had to drape the toolhead power cable over the touchscreen to keep it from jamming under the rail. The corners look a little rounded, they should be straighter, and the X and Y sides both had a little ringing, that kind of wavy pattern you see. I also noticed the filament spool was migrating across my desk instead of spinning, so I put some rubber bumpers on the bottom. For the ringing on the sides, I ran an input shaping macro suggested by someone on the Positron Discord, and that seemed to help. It just vibrates the nozzle on the X and Y axes at a bunch of different frequencies and learns how the printer responds to the different vibrations. I honestly don't know much about how that input shaping works, just that the second calibration cube I printed was a little bit nicer. Loading filament was also still a mess, but I haven't seen any mod that makes that any cleaner. For now, I just keep cleaning it up with my pliers. For my third print, I switched to the Benchy, a little boat that most people use as a quick benchmark print. I also tested printing using a portable battery because I wanted to see if I could actually take this thing with me somewhere and print stuff off-grid. The Benchy took about an hour and used about half of this battery's 256 watt-hour capacity. The printer uses between 60 to 150 watts while it's printing, depending on which heaters are going at what time. But the Benchy came out great. It was fascinating seeing the upside-down perspective, especially watching the printer bridging the roof through the bottom of the Benchy. And that brings me to the benefits of upside-down printing. Plenty of people have tried upside-down printing before, like Emily the engineer did a Benchy on an old Ender last year. She even did a sideways print. She even spun the printer while it was printing. And the worst problem she had was that the filament spool would fly off. Besides the novelty, upside-down printing still needs supports when you have a print that needs supports, and it still has all the same benefits and downsides to any other type of FDM printing. 247 Printing also did some testing and found out,
but there is zero advantage for the upside-down stance.
The main upside for the Positron is you keep all the motors and stuff in the base, making it foldable and portable. The main downside in day-to-day use is how the filament always goops up on the nozzle. Which is to say, the Positron's main party trick is also the main reason I won't be using this as my typical daily 3D printer. All 3 of these other printers I own, I can just turn them on remotely, fire off a print job, and be about 99% certain it'll print perfect every time. With the Positron, because it's made to be portable and because it prints upside down, I'll always have to babysit at least the beginning of the print. But initially, I was worried I'd have to babysit the whole print because every model I sliced, the toolhead cable would start jamming up. And initially I solved that problem in the most low-tech way possible. My kids especially liked the jank, and they also liked that I printed out a frisbee they could play with and use to annoy their siblings. Luckily, drag chains exist, and there's an official mod to install a drag chain over the Bowden tube. If you zip tie the power cable to it, then it's just enough to keep both of them out of the way of the X-axis rail. The first couple prints I tried though, they kept failing halfway through with this MCU error. Unfortunately, I had zip tied the power cable too close to the plug, and that would slowly work the cable out of place. After snipping all but the last zip tie, the toolhead cable stayed in place, and now besides cleaning up the nozzle every time I start a print, I can walk away from a print and be at least 90% sure it'll work. And so we come to the ultimate test. I broke down the printer, put it in the Pelican, and took it to the park. If I find myself completely off-grid, can I print out the things I need to survive in a suburban park on a hot summer day? Setting up the printer on my trunk took a grand total of maybe 3 minutes, and I think the hardest part was getting the filament spool to balance on my car. Since I was at a park, I plugged the printer into my little power station, and printing the frisbee left enough charge for at least 2 or 3 more prints. And the frisbee? It won't get any distance records, but at least it flies pretty straight. While I was tearing down the printer, a few people came by and asked about the Positron. It's certainly different seeing a 3D printer going outside on a sunny day. Before I wrap, there are a couple things I didn't really talk about, but I know some people will ask. Like the bed. There's no wires on it. How does it heat up? I asked about that. Apparently this is lab-grade borosilicate glass, flat to a dimension around 0.001 millimeter, and it has an ITO, or indium tin oxide coating. This conductive coating is transparent but electrically conductive, so it can heat the glass up to 100 degrees Celsius, or even a little more, but I'd leave more exotic materials to other printers. You You can also use stick glue for bed adhesion, but at least for PLA filaments like the ones I was testing, the heated bed stayed at 60 degrees Celsius and held on to all my prints. Speaking of thermals, the motors do get pretty hot to the touch after a long print, so I don't think I'd chain print all day on one of these Positrons. And there's already tons of coverage from other creators and a pretty active Discord community, so if you have the money and want to build one of these things, just dive in. And if you want to learn about the design of the printer, Kraylin has a full design video on YouTube. But that brings me to my recommendation. This kit is expensive, and it takes at least 10 to 12 hours to build. So who is it for? I could walk into Micro Center right now and pick up a Bambu A1 Mini for 200 bucks. This printer's not for someone looking for a permanent compact desktop printer like the Bambu or Prusa Mini. This printer's not a great value if you just want to get into 3D printing and you're just starting out. And it's not really a set and forget printer. It needs a little TLC to work at its best. What it is the Mazda Miata of 3D printers. It's a tiny hot rod you can customize and enjoy. It turns heads, and it dares to be different. It has a few party tricks, and people who have them probably spend a little too much time telling everyone about them. But it's just so fun, we can't help it. For practicality, there's probably a very narrow niche market for people who want to stash this in a repair truck or travel with it and might need to print off a part for production work or remote prototyping or something along those lines. But for me, I think of it more like a mini hot rod. I don't have the money or the space for a muscle car, so for my midlife crisis, this'll have to do. Until next time, I'm Jeff Geerling.